If we look below the summer triangle towards the horizon, the southern horizon there, we have a constellation called Scorpius, the Scorpion. It's a little bit more to the southwest on our screen here, so a little more to the bottom right, and it's a large hook shape of stars. That's the tail of the Scorpion. I'll put up an outline and a picture so we can see it a bit better. Now, right next to Scorpius, we have a constellation called Sagittarius. We usually look for Sagittarius by looking for the shape of a teapot. It has a handle, a kettle, a top, and a spout. You can tip it over and pour it out. And what you're pouring out is the Milky Way, that hazy path across the sky. Now, right next to Sagittarius, a little more to the east, so a little more left of Sagittarius there, we have two very bright objects. Not stars, but planets. They'll come out before you see the stars in the sky, Jupiter and Saturn. They won't always be in these spots, though. The planets move around in the sky. We find them in different places from month to month and year to year. So the planets are all going around the sun, just like we are. We're going to take a closer look at Jupiter there, the king planet, a gas giant. We're going to get an update on some recent results from the Juno spacecraft that's been out studying Jupiter. We're going to visit it by flying out to it through space. So we're going to fly out to Jupiter. It's going to get dark for a moment. You can think of this as we're getting into our spaceship. We're going to be bringing up the sky from Georgia still on Earth. Our evening sky after sunset still facing south. We see Jupiter there. Now we're going to lift off the Earth and fly out to Jupiter. Traveling hundreds of millions of miles through space. We'll see 4 of Jupiter's moons splitting off there. Those are the 4 largest and brightest moons. Jupiter has over 60 moons. Those 4 are called the Galilean moons, and you can actually see them with a small telescope when you look at Jupiter in the sky. We're closer to it now. We can see the gas giant planet, biggest planet in the solar system. Jupiter here has colorful bands across it. It's mostly a planet made of hydrogen and helium gases, but there's small amounts of other elements and molecules mixed in. Things like ammonia, water vapor, they can give different colors to the bands as they interact with sunlight. NASA sent a spacecraft called Juno out to Jupiter, and Juno got there around 2016. It's been orbiting around Jupiter and measuring a lot of things. It's been studying the magnetic field and mapping it out extensively so we can understand the internal layers in Jupiter. It also has a camera called JunoCam and several other instruments that help us look at the cloud tops, the sort of outer layer of Jupiter where we see all the weather happening. Jupiter has some very interesting weather, most famous of which is a great red spot that's been raging for hundreds of years. You actually don't see it in this view of Jupiter here because it's probably on the other side of the planet. Jupiter rotates pretty fast. It spins once about every 10 hours. So you'll sometimes see it on the front side of Jupiter facing us. Sometimes it won't be there. But we're still trying to understand all the weather patterns across Jupiter, how they're similar or very different from our own. Let's take a look at one of the pictures that Juno took of a storm on Jupiter. This is a smaller storm than the Great Red Spot in Jupiter's northern hemisphere. What we see here is that there's some bright white cloud tops, those little bright white spots across this storm. Those are areas where you see the highest level of the cloud tops. It's places where we think ammonia ice and water ice may be mixing together. And the darker areas that you see are more lower down cloud layers. Juno actually detected with an instrument some lightning in some very high cloud tops, like the bright white areas you see in this storm. We've detected lightning on Jupiter before, but not usually this high up in the clouds. It's unexpected because we usually were expecting lightning to form deeper down in the clouds. Basically, we needed pressures that are just right to have water in all three states, a gas, liquid, and solid, just like on Earth, to help develop friction in the clouds and generate lightning. And that required pressure at lower down levels. The shallow lightning, though, might be explained by water ice crystals as they get cast up and mixed with ammonia. If they mix with ammonia, then the ammonia can actually act as an antifreeze and cause the water to go back to a liquid state, and then you could generate lightning at these higher cloud layers. Let's take a look at an artist's depiction of what these storms would look like with lightning across them. These storms solve another mystery on Jupiter. Besides the high altitude lightning, there's basically pockets, patches we find across Jupiter that are sometimes missing ammonia that we think is present in the atmosphere. Now, the pockets might be due to the storms forming not only lightning, but hail. The hail is a slushy mix of water and ammonia. Scientists nickname them mush balls. The mush balls form when updrafts in the storm are lifting water ice through the ammonia water mix, and they do this over and over, adding icy layers, just like you build up a ball of hail in a storm on Earth. And just like on Earth, when the hail gets too heavy, it will fall down out of the cloud, down to lower layers. And so when you have sort of a storm of this hail dropping the mush balls, the ammonia will get dragged down out of the upper layers and cause pockets of missing ammonia. So this is a mystery that Juno has been unraveling on Jupiter. Let's take a look, end our show with a few more pictures of storms that Juno's captured across Jupiter. We see more higher up cloud tops. Storms with dark centers. The weather on Jupiter is both familiar with hail and lightning and unfamiliar with ammonia antifreeze and storms that are immense, storms that can only be found on a gas giant planet. This last shot shows the great red spot of Jupiter on the far right side, and that great red spot storm is as wide as the Earth.